All right, now we're going to talk about physical and chemical properties of matter and physical and chemical changes amongst matter. All right, so properties of matter, when we're talking about physical properties, we're talking about things that are observed or measured, but that have nothing to do with changing the identity of the matter, just physical properties. These can be color, shape, taste, density, the state of matter it's in. Is it a solid? Is it a liquid? Is it a gas? That's all physical properties. Density being an interesting one that we will talk about specifically. Okay, so physical properties generally easily identified using your senses. Okay, you can tell what color it is, you can see how it tastes, you can identify the state of matter. Is it a solid? Is it a liquid? Is it a gas? All those things fairly easily seen. Okay, other things such as the melting point. Remember, melting involves a change in state, still only a physical property because the chemical composition of that item is still the same. Boiling point also involves a change in state. Solubility, so how easily does it dissolve into other substances? Once again, still talking about physical properties because nothing chemical about the item has changed. Okay, so some of them are less easy to identify, some of them are very easy to identify, but once again, the chemical structure is not involved at all. Just the physical appearance, physical changes, things like that, nothing chemical. Density is an interesting concept. It's an interesting physical part of matter. The density of something is the amount of stuff essentially that is in a certain area. We might talk about a densely populated city such as New York, whereas there's other cities that are not densely populated, such as something in Montana might not be densely populated. There's not as many people in that area. Okay, so that's the amount of mass that is in a certain area or in a certain volume. So density equals the mass divided by the area that it's taking up, the volume. Okay, so it's the amount of substance in a certain area. And so if we're talking about that, which state of matter might you imagine is most dense? You would probably want to say a solid because it is tightly packed. We learned that solids are tightly packed together. So a solid would be more dense, whereas a gas would be the least dense. So it's the amount of stuff, right? The amount of something, the mass of something that's in a certain area, that's in a certain volume. Okay, so chemical properties. If physical properties are specific to not involve anything chemical, then a chemical property must be those chemical issues with a substance. So it's talking about its ability to react, okay, its ability to change into a new substance. So what's it likely to react with? Does it react with this? Does it not react with this? Those are all chemical properties. Those all involve reactions, chemical reactions, such as a flame. Is it flammable? Right? Is it flammable? Does it react with oxygen, right, to produce a flame? Or does it react with vinegar? Does it react with oxygen, such as iron? Right? Iron reacts with oxygen in this chemical equation here, this chemical formula. Iron reacts with oxygen to form iron oxide, which we know as rust. So when we're talking about chemical properties, we're specifically speaking as to the likelihood or the ability of something to chemically react, to chemically change into a new substance. Now we're going to see if you know chemical or physical property. Paper is white. Right, it's obviously going to be physical because we're talking about a color. The boiling point of H2O, that's water, right? Right, is 100 degrees Celsius. So boiling point involves changing liquid water to a gas, which is absolutely a physical property. Zinc reacts with hydrochloric acid and creates hydrogen gas. So absolutely, since we're talking about something that reacts, right, and creates something new, it must be chemical. Nitrogen does not burn. Right, so we're talking about burning. Absolutely, it's chemical because it's talking about if something burns, it reacts with oxygen. Sulfur smells like rotten eggs. Blech. Right? But since we're talking about smell, right, it's one of our senses, it is physical. Okay, so here's some physical and chemical properties of different substances. Helium, right? It's talking about its density, right? Density is a physical property, so it's less dense than air, which is why it rises. When we fill a balloon with helium, it rises. It's not flammable, which is fortunate, right? We wouldn't want a bunch of balloons to be flammable, which means it does not react with oxygen to form a flame. Wood, okay, wood is a grainy texture. That's how it feels, right? That's a physical property. Wood, however, does react with oxygen, so it is flammable, so that is a chemical property. And you can see baking soda, it's a white powder. It reacts with vinegar, right? That's a chemical property. It talks about reacting. Sugar, it's also a white powder. That's the color, kind of how it feels, the powdery, right? It does not react with vinegar, so it's talking about a reaction. That's chemical. Rubbing alcohol is clear and flammable. It's talking about a chemical reaction. Red food coloring is red. That's just a color, not chemical, just a physical property. But here it reacts with bleach, right? That is chemical. We're talking about a reaction. That's chemical. And iron. Iron is malleable. That is a physical property of metals, right? A physical property of metals. It's malleable. You can bend it. That doesn't change it from iron. It's still iron. You're just bending it. And iron does react with oxygen and forms rust, right? That is a chemical property. It's talking about a reaction. Talking about some changes, okay? How do we change matter? There are two different kinds of changes. You got a physical change and you have a chemical change. Okay, a physical change is when you change something, but it's still the same thing, only it looks different, but it's still the same chemical composition, okay? The atoms that make it up have not changed. The way those atoms are put together has really not changed, right? And a physical change is generally reversible. Sometimes it might be difficult, but a physical change is generally reversible. Okay, so if you tear a piece of paper, still paper, right? Physical change. If you cut your hair, still hair, but it's a physical change. If we change water into water vapor, that's a change in state. We've changed it from a liquid into a gas, but it's still water. It's still H2O. It's just a different state of matter. It's not liquid H2O. It's now a gas H2O. And chemical changes. This is very important. A chemical change is when substances become new substances having different properties. Okay, new substances formed. That's the most important part of a chemical change. We're forming new substances. Okay, these changes are not reversible using physical means because we have made a chemical bond. You can't physically undo a chemical bond. You can only chemically undo it, right? Okay, and chemical changes, right, usually cause something different, usually heat or maybe some sound, maybe some light, a flash of light, like a fire, right, that includes light. Usually they can sometimes include an odor, fizzing or foaming, right, that's going to signify that we have produced a gas. If something's fizzing, that means those gas bubbles are forming, and a color change, usually an unnatural color change. Like if you put two clear liquids together and you get blue, that's not natural. Two clear liquids together should be clear, right? Well, not if there's a chemical change. Then they might turn a different color. Okay, usually it's going to be one or more, usually more than one of these things will be an indicator of a chemical change. Some examples of chemical change. Sulfuric acid and sugar. It's going to color change, going to have some bubbles maybe, right? If you burn a piece of wood, you get heat, you get light, you get a smell, lots of different things. And when milk turns sour, you know you get a smell. Ugh. All right, indicators, very important. You can have a change in temperature. Shows you a chemical change. It can get hot, it can get cold, right? A formation of a precipitate, okay? Sometimes you're going to mix two liquids together and you're going to get some solid particles, right? That doesn't seem right. That's obviously a chemical change. Definitely changed its properties, right? I just talked about an unnatural change in color. We talked about the production of a gas, right? Some fizzing or some bubbles, some odor that wasn't there before, sound, light, all those things are indicators of a chemical change. A substance has changed into a new substance. Very important. New substances are formed in chemical changes. So, is bending a paperclip chemical or physical? Well, it's still a paperclip, isn't it? Right, it's a physical change. How about baking a cake? This sometimes is troublesome for some people. It's chemical, right? Because the batter is very different. It might have some of the same flavors, but it's definitely chemical because the reason a cake puffs up is because you've formed a gas. Those bubbles form a gas, and it's a chemical change. Sublimation of carbon dioxide, right? Solid carbon dioxide, dry ice into gaseous carbon dioxide. All right, it's the same thing. It's still carbon dioxide. It's a physical change. Crushing an aluminum can. Duh, physical. It's still the can, right? Vinegar and baking soda combining to create salt and water, okay? Vinegar and baking soda combine to create salt and water. Right, we got new substances, so it is absolutely a chemical change. So let's talk about another property of matter. It can be an acid or it can be a base. We've talked about acids, but you may not know as much about bases. Okay? There are certain indicators that will tell us if something is an acid or a base. Litmus paper, something we call pH. pH indicators, talking about how much hydrogen is in there, and a pH meter will tell you. Okay? There's a pH scale that tells whether something's acidic or basic. The bottom of the scale, the lower numbers are more acidic. The higher numbers are more basic. Okay, and this happens because a water molecule can break apart. So things are acids or bases depending on whether they are made up of, it's got some hydrogen ions or what we call hydroxide. Oxygen and hydrogen together. Okay, hydrogen being a positive ion, this hydroxide being a negative ion. Acidity or basicity is determined by the presence of those ions. So the concentration of those ions determines whether it's an acid or a base. High concentration of hydrogen, right? That's acidic. High concentrations of hydroxide indicate bases, right? If there's an equal concentration, then you might have something that is considered neutral. So more hydrogen, more acidic. More hydrogen, more acidic. All right, so we need to copy down these properties of acids and bases. It's going to be important. Okay, an acid's going to taste sour. Okay, it's going to be less than a 7 on the pH scale. It's going to change litmus paper from blue to red. These formulas for acids are going to start with an H. It's going to start with some hydrogen because they have that hydrogen in there. Okay, sometimes we can use acids in food, like vinegar is an acid. Okay, it's going to feel kind of squeaky in your hands, and it's going to have more hydrogen. Okay, a base, they're going to taste bitter. Okay, a base is going to be greater than 7 on the pH scale. It's going to turn litmus paper from red to blue. It's going to end in that OH, that hydroxide. We use bases as cleaning products. They're kind of slippery in your fingers. Okay, and once again, more hydroxide. Okay, so let's talk about this pH scale, right? This is that scale. The lower it is on the scale, the more acidic it is. Like battery acid, very acidic. Not good for you at all. Sulfuric acid, also very acidic. Lemon juice, and vinegar, those are acidic. Might give you some heartburn, right? It might burn if you get it in a cut. Orange juice and soda, those are also acidic, but we're going up. We're getting closer to that neutral on the scale. Acid rain and maybe a lake with some acid in it from that acid rain is going to be a pH scale of 4. Unfortunately, at 4.2, all the fish are going to die. We don't want that to happen, right? And a pH of 5, you might have bananas, some clean rain, right? But still going to be killing some animals. Not good. Not good, okay? We want the pH of our water to be 7 or above, so we're not killing these animals, right? Baking soda is a pH of 9. Milk with magnesia, might use that to soothe the burning in your heartburn from lemon juice and orange juice, right? Ammonia, soapy water, bleach, all right? As you get a higher pH, more basic, it's more of a cleaning product, right? Acids and bases. Using the pH scale to identify whether they have more hydrogen or more hydroxide. All right, we're going to work with some acids and bases in class. We're going to talk more about them. We're going to definitely work with chemical and physical changes and chemical and physical properties, especially that density. Got to remember that density. Density equals mass divided by volume.